This section is 4.3, dividing rational numbers. So we've got our steps here on how we divide decimals. So what we do is if our outside number, so our outside number as in like when we're doing long division, isn't a whole number, move the decimal point to the right to make it a whole number, and then move the decimal point under the division sign the same number of places. Then we're going to divide just like we would do in long division, and then we put the decimal point directly below, above in the answer. Okay, so let's do one here. So we've got 8 divided by negative 2.5. Okay, so we're going to do long division. So we're going to do our division sign like that. Our two numbers here, we've got 8 and we've got 2.5. Again, just kind of like when we did multiplying, I'm just going to ignore the negatives for now and then deal with those at the end. So when I do this, my first number is the number that goes underneath my division here. So I'm going to put the 8 under there, and the 2.5 is going to go outside. So my 8, my first one, goes under my division, and then my 2.5, my second one, goes outside of my division. Okay? It's always going to follow that same format. So whatever's listed first goes on the inside, whatever's listed second goes on the outside. Okay? So now, following my rules from up here, if my outside number, so the one that's outside that division bar there, isn't a whole number, so basically if there's a decimal place in it, then we have to move it to make it a whole number. So here my 2.5 has a decimal, so what I need to do is I need to move it to the right so it's no longer a decimal. So I'm going to move it over one space, so now my number here is 25. So now if I do that, I also have to take this number here underneath my division sign, and I need to take that and also move that over one space. So now, instead of taking 2.5 and dividing it, instead of taking 8 and dividing it by 2.5, I'm taking 80 and dividing it by 25. So basically all I did there was I took the 8 times 10 and the 2.5 times 10 just to make the decimals go away. Just makes it a little bit easier to deal with. So then when we write our answer in here, our decimal point is going to go directly above where we moved it to. Okay, so now what we do is we divide, just like we would do in long division. So we want to see how many times 25 would go into 80, which would be 3 full times, because if we take 25 times 3, that would be 75. So then I do 80 minus 75, which is 5. Then here, since I don't have another number, I need to put a 0 there, so I have something to drop down. So now that's going to change to 50. Then I want to see how many times that 25 will go into 50, which would be 2 times, because if I take 2 times 25, that would be 50, and that actually comes out evenly. So then my number there is 3.2, and since I took my decimal point and put it directly up there, I'm basically done with that. So 3.2, and then again I've got to look at my positives and negatives. So I've got different signs here because it was a positive divided by a negative. Different signs is always going to be negative. So negative 3.2. So that would be our answer for that one. Then we'll jump to the next one here. So we've got negative 9.3 divided by negative 0.3. Okay, so when we write this out, remember the first thing is going to go on the inside. So my first number there, 9.3, is going to go under my division bar, bracket, I don't even know what those are called there, under the division. And then my second number goes on the outside, so 0.3. Then again, since my outside number has a decimal point in it, I want to turn that into a whole number. So I'm going to go over one position there. So now I'm going to have 3. And then the same thing here, I want to go over one position and make that 93. So now I'm taking 93 and dividing it by 3 instead of 9.3 divided by 0.3. Okay, so I just took those numbers times 10 basically, but it's the same problem. So now my decimal point is right there, so I bring that directly up in my division. Now I want to see how many times 3 goes into 9, which would be 3 full times. 3 times 3 would be 9. So then 9 minus 9 would be 0, so that comes out nice. Then I'm going to drop down my 3. So I want to know how many times 3 goes into 3, which would be 1 time. And then 3 times 1 would be 3. 3 minus 3 is 0. I got nothing else to drop down there. So my answer is going to end up being 31. Then if I look at my symbols here, I took a negative times a negative, so that would be same signs. So it would come out to be a positive 31. Okay, so on page 154, try out A through C, and then I'll get you the answers. So let me flip to the right page here. Okay, so for A, they got negative 6.4. B, they got negative 1.3. And C, they got 7. Okay, so hopefully you got those. Next thing here is multiplicative inverse, or these are also called reciprocals. So what that means is the number that when multiplied by a given number results in a product of 1. So an example here would be like 1/5 and 5. Okay, because when we multiply those together, if we put the 5 over 1, 1/5 times 5 over 1, the 5's can reduce down to 1 and 1. So we multiply those out, they become 1. Okay, so basically what you do to get its reciprocal is you take the fraction and you flip it over. So 1/5 would flip to 5 over 1. Or if it was like 2/3, our reciprocal of that would be 3 over 2, because we're just taking it and flipping it. Now if this was a negative 3 over 2, then this would be, a negative 2/3, this would be a negative 3 over 2. Okay, so we're going to use that when we do our dividing of fractions. So basically what we do to divide fractions is we're going to keep our first fraction exactly the same. Then we're going to change our symbol from division to multiplication, and we're going to flip our second fraction over or multiply by the reciprocal. So dividing is actually the same thing as multiplying by the reciprocal. Okay, and the more practice we do of this, the more sense it'll make. So the first one here, we've got negative 12 divided by 2/5. So the first thing I'm going to do there is I'm going to change the negative 12 to a fraction. Then I'm going to follow my rules. So I'm going to keep the first fraction the same. So I'm going to keep it negative 12 over 1. Change my symbol from division to multiplication. Then I'm going to flip my second fraction. So instead of having 2/5, I'm now going to have 5 over 2. So keep, change, flip, keep my first fraction the same, change my sign to multiplication, flip or multiply by the reciprocal. Okay, so then I just multiply like I was doing the other day. So I've got negative 12 over 1 times 5 over 2, so I look the diagonal ways at the 12 and the 2. I know I can pull a 2 out of both of those, so if I pull a 2 out of 12, that would be 6 or negative 6. And if I pull a 2 out of 2, that would be 1. 1 and 5 can't reduce down at all, so then I take top times top, so negative 6 times 5, which would be negative 30. Bottom times bottom, 1 times 1 would be 1, so this would be the same as just a regular negative 30. Okay. Next one here, we've got 2 3/7 divided by 1/2. So here, since I've got a mixed number, I want to change that into a improper fraction. So I'm going to take the 2 times the 7, which is 14, plus 3, which would be 17. So 2 3/7 is the same thing as 17 over 7 divided by 1/2. Then I follow my same rules as before, keep my first fraction the same, so 17 over 7, change my sign from division to multiplication, then I flip my second fraction. So it changes to 2 over 1. Then I see if there's anything that can reduce, so I've got 17 and 1, nothing can reduce there, 7 and 2, nothing can reduce there, so then I just take top times top, so 17 times 2 is 34. Bottom times bottom, 7 times 1 is 7. So 34 over 7 would be my answer. Now I could also take and turn this into a mixed number. So I would want to see how many times that 7 can go into 34, which would be 4 full times at 28, and then there would be 6 out of 7 left over. Okay, so either of those two answers would be acceptable on the test. Alright, next thing here, we've got example 3, which we're going to go off of the recipe that's on page 155. So they've got a recipe there for raspberry almond cookies, and it says we're supposed to have a 1 cup of butter, 2/3 cup of sugar, half a teaspoon of almond extract, 2 cups of flour, and half a cup of raspberry jam. And this is going to make 2 dozen cookies. Okay, so 2 dozen cookies is 24, 1 dozen cookies is 12. So what it says here is we want to know how much sugar do we need to make 1 dozen cookies. So instead of making 2 dozen or 24, we just want to make a half batch. We only want to make 12. Okay, so basically what we need to do is, since we need to make half as much as we originally needed to do, we need to take this recipe and divide these values by 2 or multiply them by a half, right? Because we want to cut them down. So sugar, it looks like in our recipe, was 2/3 of a cup. So 2/3 of a cup of sugar. And if we just want half of that, we're basically dividing our recipe in 2. So what I would do here is I would then take 2, since I want just half the recipe, and I'm going to turn that into a fraction. So when I do this here, since it's division, I keep the first fraction the same, so 2/3, change my sign from division to multiplication, and then I flip my second fraction. So I'm going to flip it to 1/2. So if I divide something by 2, that's the same thing as multiplying by half. Okay, so dividing by 2 and multiplying by half will get me the same answer. So then what I do is I'm going to see if there's anything that can reduce. So the 2's will reduce. Both will go down to 1 because we can take them and both divide by 2. 3 and 1 can't reduce at all. So then we do top times top. So 1 times 1 is 1. 3 times 2, or not 2 anymore, 3 times 1 is 3. So a 1/3 cup is how much sugar we're going to need. And if you think about it logically, if we needed 2/3 of a cup for 2 dozen, and now we just want 1 dozen, wouldn't 1/3 make sense for half of 2/3? Because 1/3 and 1/3 together makes 2/3. So logically that kind of makes sense. Alright, next thing here is some for you guys to try. So on page 156, try out D through F. And I will get you the answers here. So D, they got -21. E, they got 18 over 35. And F, they got 5 over 84. Okay, one more example here. So it says evaluate 3 over x if x is equal to -3/4. Okay, so we know when we've got a variable like this and they tell us what that variable is equal to, we can just take and plug that in there. So instead of the x, I'm going to plug in -3/4. So I've got 3 divided by -3/4. Now what can get kind of tricky here is this is basically like a fraction inside of a fraction, and that's kind of goofy and that's kind of hard to kind of wrap your mind around. So I know fractions like this are the same as division, so I could basically rewrite this as 3 divided by -3/4. That would be exactly the same as what's written here. Okay, so if that big fraction like that confuses you, just rewrite it like this so it makes a little bit more sense. Then what I would do is I would take the 3, turn it into a fraction. So I'm going to keep my first fraction the same, change my sign to multiplication. So first fraction will stay as 3 over 1. Sign's going to change to multiplication. Then I'm going to take it, I'm multiplying by the reciprocal, so I need to flip the second fraction. So -4 over 3. Still keeping that negative with it. So then if I see if I can reduce anything, so I go the crossways. 3 and 3 can reduce because I can divide both of those by 3, which would be 1 and 1. 1 and 4, nothing I can reduce there. Then I take top times top, so 1 times 4 is 4. Bottom times bottom, 1 times 1 is 1. This was a positive, this was a negative. So negative 4 over 1, which would be the same thing as negative 4. Okay? Alright, last thing there on page 156. Try out G through I. So for G, they got 10. H, they got negative 3/10. And I, they got 20 over 21. So hopefully you got those. Okay, so that's the last part of our notes there. So your book page assignment is page 157, 18 to 44 even.